Hello students, welcome to my YouTube channel. I Dr. Om Teraya. Today we are going to start a very important part of the engineering mathematics, that is vector calculus students. It is a very important topic as far as the engineering maths is concerned. The use of the vector calculus can be in the physics, electronics and the electrical branch students. Now in this unit we shall study the following topics students. Number 1, what is vector quantity? Number 2, what is scalar quantity? Number 3, vector point function. Number 4, scalar point function. Number 5, vector differentiation. And number 6, del operator. Number 7, gradient of a function and its physical meaning. Number 8, and related is examples. Number 8, directional derivatives. Number 9, divergence of a vector and its physical meaning, and we'll see the examples. The next is curl of a vector and its physical meaning. And its example, students. Then we'll see line integral, and related examples. And we'll see Green's theorem and its examples. Then we'll look at divergence theorem, and its examples. And last we'll see that's fine. So these are the point that we'll cover in this unit, students. First we'll see what is vector quantity, what is scalar quantity, what is vector point function, what is scalar point function, what is vector differentiation, what is del operator. Based on that we'll see the gradient of a function and its physical meaning and its example. Then we'll see the directional derivative, divergence of a vector and its physical meaning, curl of a vector and its physical meaning, line integral and related example. Then we'll see two theorems, Green's theorem and divergence theorem and its example, students. So let us start with the very first point, that is vector quantity. So what is vector quantity, students? Our first definition is vector quantity. So what is vector quantity? That you have already been studied your 12th standard, students, but here we are recalling the vector and the scalar because the whole chapter is belonging to vector and the scalar, students. So vector quantity means AC quantity, a quantity in which magnitude and direction both occurs. वेक्टर क्वांटिटी एक ऐसी फिजिकल क्वांटिटी है बच्चों कि जिसके अंदर मैग्नीट्यूड भी है, डायरेक्शन भी है. सो हम एक से एग्जाम्पल दे सकते हैं. फॉर एग्जाम्पल, वेलोसिटी, जिसके अंदर मैग्नीट्यूड भी है, डायरेक्शन भी है. वेलोसिटी, acceleration, then you can say force. So these are the examples of the vector quantity, students. And vector can be denoted by like this: vector p, vector q, vector r, etc. The meaning of magnitude is, if we have this origin O, and if you want to find the distance of P from the origin, then this can be known as magnitude, students. So you can find like this: OP is equals to something scalar value. So this gives us the magnitude of the vector OP. It means we are finding out the distance from origin to the vector P, students. Now we'll move to the next point. And number 2, that is scalar quantity. So what is scalar quantity? A physical quantity in which magnitude is there but a direction is not occur. So what is scalar quantity? एक ऐसी क्वांटिटी है बच्चों, it gives you the magnitude, it has a magnitude but it doesn't have the direction. That you have studied in your 12th standard. Let us take the example. For example, weight, age, mass, density of the body. These are the example of the scalar quantity, students. Now we'll coming to the most important part, that is vector representation vector representation in R3. So how can you represent the vector in R3? So vector can be represented by one function in R3, like f x y z is equals to xy I caret yz j caret zx k caret, students. So vector can be represented by a function capital F x y z x y I caret yz j caret zx k caret. This can also be written as xy comma yz comma zx, where I, j and k caret are the unit vector along the direction x y z axis, students. So what is ijk? Ijk are the unit vector along the direction x y and z axis, students. So this is how we can write the vector quantity as well as the scalar quantity and vector representation in R3, students. Now we'll move to the next point is vector vector differentiation. What is the explanation of vector differentiation that we are going to see? Say for example, we have one vector f of t. This can be written like this, which is equal to x square which is equals to 2t square I caret plus t cube j caret plus 4t raised to 5 k caret, students. So the vector differentiation is very similar to the ordinary differentiation that you have studied in your 11th and 12th standard, students. So now we'll find the derivative of this function with respect to t. So you can write df by dt is equals to, what is the derivative of t square? 2t. So 2 2s are 4t I caret plus 3t square j caret plus 20 t raised to 4 k caret, students. So this is a very simple ordinary differentiation of the vector, and this first derivative of the given function gives velocity, students. Now we'll find the second derivative of the f with respect to t. So we'll write d2f by dt square, which is equals to, again we'll take the derivative of this function with respect to t. So it gives us 4I caret plus 6tj caret plus 80 t cube k caret. So this is the second derivative of the given function f, students. Now this quantity gives us acceleration of the given physical quantity, student. So once you find the first derivative of the given vector, it gives you the velocity, and when you find the second derivative of the given function with respect to t, it gives you acceleration, students. So this is how we can represent the vector differentiation, students. Now if we have f x y z is equals to 2x square I caret y z square j caret plus z square x k caret, students. So here we have given x, y and z in terms of the vector. So here we have found the derivative of the vector, but now we'll find the partial derivative of this function with respect to x, y and z separately. So here you can also find del f by del x. Partial derivative means you have to take the partial derivative of this function with respect to x. So when you find with respect to x, y and z can be treated as constant. That you know it very well how to find the partial derivative. So you can find del f by del x, then you can also find del f by del y, and you can also find del f by del z. So this is how we can find the partial derivative of given function with respect to x, y and z. So here you can write 4x I caret, there is no x term, so this becomes 0, so this is 0j, and here it is x, so you can write z square k caret because z square is a constant. Similarly, you can find the partial derivative of this function with respect to y. So there is no y, so it is 0i, y is there, so 1 into z square is z square j caret, and there is no y, then this become 0 k caret, students. Here you can also write 4x 0 and z square. This is also one of the vector form, students, and here you can also write 0 z square and 0. And now we'll find with respect to z. So this is, there is no z, so this is 0 I caret, z square is 2z, so 2y is z j caret, and here z square is again 2z, so 2xz k caret, which can be written as 0 comma 2yz comma 2xz students. So this is how you can find the partial derivative of the vector like this. So ये सोचने this thought has given a very beautiful idea of the vector point, that is a del operator, that is del operator. Here if you find d by dx, this is also operator, but this is called vector differential operator. This is called vector differential operator. And if you find the partial derivative with respect to x, y and z, and if you add these three quantity, then it generates the del operator students. So in next lecture we'll start from del operator, what are the application of del operator, and we'll see some example based on the del operator students. So I hope that this lecture would be clear into your mind. So kindly subscribe and like my channel, and in next video we'll see what is the del operator and the application based on del operator students. Thank you very much.